So finally, I just want to talk about a couple of issues that you'll always face when you're doing tracking. So the first one is initialization. How do you start the thing? And there's no good answer. The examples I showed you before were done manually. Somebody says, oh, track that. Okay, so you draw a little circle, say, keep track of that thing. You might have a background subtraction method. Okay, so every now and then you may be able to subtract out a background, find the objects and say, okay, keep track of that object because it's isolated, and I'm going to track it as it moves along even when it becomes like partially occluded or with other moving things in the way. Or you might have a detector that can detect things when they're clear and fully visible, right? So I've got a bank robber detector. No, I might have a particular car detector, and I say, a Jeep has just showed up, follow that Jeep. So the detector is running, and it'll only fire sometimes when it gets a good clear view of something, but then you want to track and follow it through. Next question is, where do you get your sensor and your dynamics models from? Well, we've talked a little bit about this. Your dynamics models you maybe can learn by essentially from real data. That's generally pretty hard because if you could track the real data without the dynamics model, you wouldn't be using the dynamics model. So you might use it from clean data. Remember we talked about the girl jumping in front of the black background? That would be some clean data. Or it says here you might specify domain knowledge. That means you're like the smart person. You just write down what it is. Or you take another trip to Delphi and you get another thing from an oracle. Now for the observation model, typically it says generative observation model. What that means is, remember we did the model for the robot sensing distance? So if I knew the wall was 3 meters away and I take some measurements and I collect them and I get a distribution, now I know what my distribution would be. The trick is I had to know that the thing was actually 3 meters away or 2 meters away, right? I have to know the ground truth. So you have some sort of absolute sensor measurement. Prediction versus correction. So remember this whole thing about tracking and inferences. I make some prediction, I take some measurements, I do my correction. The question is, what's that relative trade-off? Remember we talked about this in Kalman filter, which basically came down to what's the relative size of the noise of my measurements versus the noise of my process? Actually, we usually do the other way around. The noise of my process versus the noise of my measurements. And if one is too strong, you'll ignore the data. If the other is too strong, you'll ignore the predictions. So getting those balanced right is just a little bit of magic that you have to do based upon looking at the data. Here's a more interesting, or I should say fundamental one, and it's referred to as data association. Data association basically is, what if we don't know which measurements to associate with which tracks?